Hello everyone. In the previous video, we learned about the binary number system, how to convert decimal to binary, binary to decimal, and all the stuff like that. This was to prepare you for learning the working of 74HC595. We need to know what binary is. In this video, we are going to learn the working. So when I explain the working to you, I will be explaining to you about the data in pin and the latch pin and the shift clock pin. So when I do the explanation, please remember these three pins: pin number 11, pin number 12, and pin number 14. Before I explain the shift register IC, let me explain an analogy to you. This is the setup of a racing car track. We have cars coming in from the parking lot. So these are cars which are coming on a single road. They are not racing with each other. They are coming in a single road, one after the other. So that means car C8 comes first, then C7, then C6, then C5, and so on and so forth. These are simply cars coming in so that they could be lined up at on the tracks. So that they could be lined up on the tracks. Now, this part of the track is basically where they are lining up. They will not start racing yet. They are simply lining up. They will start racing when actually the cars come into this area, which is the ready to go area. And when it comes into the ready to go area, when they come from the cars lining up area to the ready to go area, then they start the race. And they go out of these tracks. So that means there are 8 tracks and they will go out of these tracks. Let us see how the movement of the car is going to be. That means car C8 will come into the track first, and let us see how things are happening. So C8 has come into the tracks. That means the lining up area. It will not start racing yet, but the cars from this area, the first car has come into the cars lining up area. Let's bring in the second car. Now you saw that when car C7 came into the tracks, it shifted C8 up so that the space could be made for C7. Similarly, if I bring in another car, it will occupy the space of C7 and C7, C8 will move up. Now you will see that after we shift all of them, C5 also, you can see that C5, 6, 7, 8, they will be shifting up, shifting up, shifting up, shifting up. Now see what happened. Cars actually were coming one after the other on a single track, and they have come now onto parallel tracks. That means 8 tracks. They are still not ready to go. They will be ready to go only when they come into the ready to go area. So let's bring them into the ready to go area. They are now in the ready to go area, and when they come here, they start the race. Now you have understood the process now. Okay, let us see this process again. So once I start, the first car moves into the cars lining up area, second car moves, third car moves, fourth car moves, sixth, seventh, and eighth. All the cars have lined up now. After the lining up, the second next process is that these move into the ready to go area. They are now in the ready to go area, and this is now they will start racing now. I hope then this analogy is very clear to you. So they start off from a serial track and come in actually into parallel tracks, and in the parallel tracks you saw that they were shifting each other. After we saw the cars racing analogy, let us now see the actual working of a shift register. A register actually means a storage. Okay, so we'll talk about storage in just a few minutes. Now, in this system, a serial stream is coming from the Arduino. So that means from one pin of the Arduino, a serial stream is coming. So serial stream actually means there is a single wire taking out these bits. Okay, so that means this 0 comes first, then 1 comes 1, then comes 1, then comes 0, and so on and so forth. So each one of these are coming one after the other, and they are supposed to be shifted to the bits lining up area. So you saw that in the car racing analogy also. So these will be coming into this area where the bits are going to be lined up, and they are going to be shifted again the similar way to the cars. The bits which are lining up here will not actually produce any result out from the IC. Why? Because they are not ready to go. They will, when they will be ready to go, they actually are supposed to come into the ready to go area, and then they will actually come out from the 8 pins of the IC. Let me show you the working of this system now. The first bit moves into the bits lining up area. Now you can see that 0 has come, the last 0, that is the least significant bit, has actually lined up. Next, the next one has lined up. So 1 has lined up. Next, the next one is going to be lined up. And you can see that the bits are shifting up. That is why we call it as a shift register. The bits are shifting up. So again, so let us shift all of them. So after you have shifted each one of them, the stream is empty now, and all the bits have actually gone into the bits lining up area. That means they are now lined up with each with 8 pins of the IC, and they are ready to move out now. So when they are ready to move out, they have to be brought into the ready to go area. So let's bring them into the ready to go area. They are now in the ready to go area. So the entire bits from the series have come into the parallel stream, and they are now in the ready to go area. So when they are in the ready to go area, they are actually, their result show on the pins, and whatever is connected to those pins, there are LEDs connected, there are motors connected, there are any kind of an output which is connected, will start working according to the zeros and ones. For example, anything connected to this particular pin will be switched off. Why? Because it is a 0 here. On this pin it is a 1, so it is going to be switched on. This is going to be switched on, and so on and so forth. I think you've got the situation now. Let me explain this thing again. I have renamed these two as the clock shift and the latch shift. Okay, what the clock shift does is it shifts each of these uh, bits into the clock shift area. Okay, so into the clock shift register, and keeps it there. It is not ready to move out of the IC right now. So let us now start the process of shifting. So the first bit, second, third, fourth, fifth, sixth, seventh, eighth. The clock shift actually works on the internal clock of the IC. So with each internal clock, it shifts one of the bits into the clock shift area, into the clock shift register. So once this is done, the latch shift starts now. So latch shift actually works one after every 8 clocks. So once these 8 have been shifted in, the latch shift starts working. So it basically shifts once, all these will shift to the latch shift area. And then the result of these zeros and ones are visible onto the pins. So whatever is connected to the pins will start working or not working according to the zeros and ones. Now that we know how this IC works, let us focus on all the pins now. We have already seen pin number 14, pin number 12, and pin number 11. So pin number 14, 12, and 11. These are the three pins which are actually connected to Arduino. We will be requiring only three pins from the Arduino. They will be connected to this IC, and this IC will provide the further information to us. So where are the further 8 outputs going to come as the parallel output? You know that DS is the serial input. Now Q0, which is the first pin out of for the parallel output. This is first pin, that is pin number 15. Then the second, third, fourth, fifth, sixth, seventh, and eighth, that is pin number 1 to 7. So that means pin number 15 and 1, 2, 3, 4, 5, 6, 7, these are used as the parallel outputs. So that means one serial input will be coming from pin number 14 and parallel outputs are going to come from pin number 15, 1, 2, 3, 4, 5, 6, and 7. So basically you will be connecting pin number 14 to the Arduino, which will receive information from the Arduino in serial form. And the LEDs or motors or whatever are to be connected are going to be connected to Q0, 1, 2, 3, 4, 5, 6, and 7 pins. Okay, this part done. Pin number 16 is for VCC, that is connecting to the 5 volt positive, and pin number 8 is for the ground. So both are on the opposite corners. So that means the last pin is basically on this side is VCC, and the last pin on this side is actually the ground. That done, we have two pins now. One is called as output enable or enable output and master reset. So enable output basically is connected to the ground if you want the output to come out. All right. So if enable output pin is connected to positive, nothing will come out of the IC. So that means the input will go, but output will not come. The latch will work, the clock will work, everything will work. But if enable output pin is positive, nothing is going to come out of the pin number 15, 1, 2, 3, 4, 5, 6, and 7. Master reset, if it is connected to high, it is okay. When it is low, it will set the output pins to 0. So that means all the output pins are basically going to be 0 if the master reset is given a low. So you can see that output enable pin number 13 is normally grounded so that it is enabled. The output can come out. Pin number 10 master reset is normally high so that the information of the IC is retained. Let us understand what that pin number 9 is for now. This is the first IC that is connected to Arduino, and Arduino is directly connected to pin number 14, which is the data N. Now, one IC is basically responsible for serial in parallel out of 1 byte, that is 8 bits. Suppose your data is more than 1 byte. That means suppose you want to connect the ICs to 16 LEDs or 24 LEDs. How do you connect them? Now the Arduino is connected to the first IC's pin number 14, that is data in. Pin number 9 is the data out, so whatever is the excess data that will go to the pin number 14 of the second IC. Similarly, whatever is excess data from pin number 9 of IC number 2 can go to pin number 14 of the third IC. So this is how you can daisy chain a number of ICs together. So the first Arduino pin is connected to pin number 14 of the first IC. Then pin number 9 of each IC is connected to pin number 14 of the next IC. Pin number 9 to the 14 of the next IC. This is how it works. I hope the working of the shift register and the pins are clear to you. We will work with the actual shift register on Tinkercad and create a program and create a circuit.